Everyone, welcome and thank you for being here. My name is Sarah Burnstead. I'm with the Movement Ecology and Reproductive Resilience Lab that is led by Sue Lowry-Barbieri, and we're based out of the St. Petersburg headquarters. This summer we had 5 interns, which is unusual for us. In the past, we would have one usually over the summertime. And we've had them do a variety of things, but one particular data set has worked really well with our internship program, and that's analyzing passive acoustic sounds from spawning fish, in particular spotted sea trout, as we've been monitoring a residential spawning aggregation of sea trout in Tampa Bay since 2004. So it's a really unique spawning site. We have a great opportunity to collect a lot of data, but then there's a lot of data to analyze, and it's time intensive as you have to listen to the whole set. So the interns have been doing an amazing job this summer. Each one has a different data set to listen to, but collectively they trained together. We did, of course, all of this remotely with COVID. So our interns were spread out throughout the state and then even in Texas. But we had a great experience with everyone. And 3 out of the 5 interns chose to do presentations. So we heard from 2 earlier this week. And today we'll hear our last one. The other 2 are opting for papers. So we're going to be hearing from Michelle Huang. Michelle is a rising junior at the University of Florida. She is working towards dual degrees in marine science and sustainability studies. Michelle, since last spring, has been working in the Martinique lab looking at effects of different compounds on zebrafish. So she's already dipped her toes into the scientific pool, and I believe is going to be doing more research as well next year. So Michelle today will be speaking to you all on comparing and predicting the spawning patterns of spotted sea trout in Tampa Bay, Florida.
All right, thank you, Sarah. So yes, this is my presentation on what I've been doing this summer with the MERR lab and how it all went and the data that resulted from it. So, the focus of this internship was the spotted sea trout, also known as the Cynosian nebulosus. And this fish has an extended spawning season, and it's really special in that it has recreational significance. It's important for fishers in the state of Florida, so it's important that it is managed well, and this data can help with that. So their spawning season can be single or bimodal, but it's more common for it to be bimodal. So there are peaks in April and May, and also July and August. And they're also special in that they have high site fidelity, which means they're loyal to one area for spawning. And specifically in Tampa Bay, their spawning season lasts from mid-March to October. And one of the ways that their calls can be distinguished would be with pulse duration and also the intensity of their sound, which we listened to as a part of the internship. So with the internship, the goals were to listen to and analyze audio files from the spawning season in Bunce's Pass and identify the spawning periodicities of the species for 2017, which was my year, and then relate these patterns to other seasons of data and environmental conditions. So for the study, why Bunce's Pass? So there were preliminary studies that where the MERR lab sampled multiple sites, and they found that Bunce's Pass had unique site fidelity. As I mentioned before, the spotted sea trout would come into this specific area every year consistently, so there were some factors that just led to them being really loyal to the site. And the site that I listened to files from was Site 1, as shown in this map, in Bunce's Pass in Tampa Bay. And as Sarah mentioned, they started monitoring this area in 2004, so there's a large data set. And so these files were mailed to the interns via a hard drive, and then we appended these days using Audacity, which is an audio software where you can edit and listen to audio. And then we recorded the data and analyzed it in Excel. So for the logistics, there were multiple LARs, also known as long-term acoustic recording systems, and they were deployed using scuba at 28 feet deep, which is the maximum depth of Bunce's Pass. And then ever since they're deployed, they have recorded 10 seconds every 10 minutes, just consistently. And then for me, Logger H was deployed on March 2nd, and then they were switched out on May 2nd and replaced with 2 loggers, A and J. And then the available data for me was from March 2nd to August 10th because there was equipment failure after August 10th. And even though the logger stayed deployed and it malfunctioned, the spawning season would still technically last past that and into October. So here's some reasons why we use passive acoustic monitoring. For one, it's effective and non-invasive for the fish, and it can record data for prolonged periods of time. And this is good for having enough data for management and to look at how a spawning site is used over time. And a study on captive sea trout indicated that there was a direct correlation between calls and spawning behavior. And it showed that fish were more likely to spawn when male fish were calling, and that eggs were only released when producing calls. And so the process that the interns went through was to append the files into 24-hour days, and then we set it to a spectrogram mode, which I can show you later, and then we listened to it and recorded the data points that you see here. And then we also took note of disturbances and other sounds that we made comments on. And this is repeated throughout the whole set of data. And so the most important data point here is the estimated number of trout. So we have 1, 2, 3, and 5 for these different categories. So 1 to 2 individuals, 3 to 5 individuals, a small aggregation, and a large aggregation. And there's a reason why 4 wasn't used. It used to be used for a medium aggregation, but they would always group it with the 5 as well, and it would still be counted as spawning. So we just thought using, and it would also it would be hard to distinguish sometimes between a 4 and a 5, so that the 4 was just taken out. And it's important to note that this is just a conservative estimate, and that it's not necessarily that only spawning occurs at the 5 level. It's just so we can have a higher confidence in that there's spawning at that point where there could still be spawning at a small aggregation level or lower. And so this is what the interns looked at and listened to throughout the summer. So we have here a sample of audio from Audacity, and it shows that it's the frequency in hertz on this side, so it's from 0 to 8,000 hertz. And these are some of the commonly heard fish that were in the file. So this is silver perch, also known as Bardiella, and then the sand sea trout and spotted sea trout. So the silver perch sounds are in this higher range here, and they have a higher pitch and can be heard pretty distinctly. And for me, and I think this is a usual trend, they are heard in the first half of the season predominantly, and then for me, they died out in the second half of the season around July and August. So it was mainly these sounds after the second half. And the sand sea trout and the spotted sea trout both have similar frequencies. So it's hard to tell visibly if each of them are present or not. And so it's important that people are here to listen to the files because it can't be analyzed by computers. And since they're audibly distinct, it's easier for us to hear it than a computer to analyze it and figure it out. Yeah. Just a side note as well, the sampling rate of the sampling rate was 16,000 hertz, and then Audacity showed up to 8,000 hertz. And the human hearing range for sound is from 20 to 20,000 hertz. And so here's some examples of the 24-hour span of time and what the files would look like. And as you can see on the right, the Bardiella would show up in the evening time as well as the Seatrout. And so that's the time that we would focus on when we listened to the sound. And yeah, there were prevalent Bardiella aggregations at the beginning, but not at the end, as you can see between these two files. And then the boats, you can see in the top one here, there are these lines that go up to 8,000 hertz, and those would be the sound of boats. And it's important to know where they are so you can avoid hearing a really loud boat sound. But all these boats indicate that it was either a weekend or a holiday, so there would be high boat traffic. That's just an interesting fact. But yeah, the second one mostly shows Seatrout sounds, and it's good. And then there were also disturbances in sound. You can see these white spikes, and they happened a lot in July, and it would also be hard to listen to, but luckily we had 2 loggers for that period of time, and I just had to append the files for the other set of data, and it didn't show up in the other set. And these disturbances were likely caused by floating seagrass or other debris that caught onto the logger and kept hitting against it. But yeah, that shows that it's important to have multiple loggers in case issues like this show up. And then an interesting thing that I found in my data was that there were fluctuations in the intensity of sound. As you can see here, it's like lighter and then darker, and also in this area as well. This was unusual because it's usually a consistent level of sound throughout, and it could either be many factors, like natural variations in their energy level or temperature, or also the presence of predators like dolphins and sharks. And yeah, it was not common in past years for this to happen, but it happened quite a lot in my data, so that was just an interesting thing that happened. And then now to look at the data. So this is the data for any level of sound in 2017. And yeah, it shows the duration of sound in hours and then the months on the x-axis. And you can see that there are peaks in sound level and sound duration. And then I also took data from the National Oceanic and Atmospheric Administration, or NOAA. They have a sensor at Clearwater Beach, which is 10 to 15 miles north of Fuentes Pass, and it showed the temperature data, which we felt comfortable enough comparing because of the close proximity to Clearwater Beach and Fuentes Pass. And so there's a really interesting correlation between temperature and the duration of calls, as you can see here. And even like at the beginning, there's a small dip here and here. So I thought it was interesting. And also note that the turn-on temperature for spawning for Seatrout is 23 degrees, and that would be this line here. And you can see that the temperature range here correlates kind of with this pattern. There's like a little peak here and then a little peak there, and it kind of matches with the temperature as well. But I also noticed that this is the 3-hour threshold, which is the standard for when the spawning season starts. So if there's a consistent level of 3-hour sound throughout each day, then it's a good approximation for the start of the spawning season. But that didn't happen for me until the end of June and July, so it was just an interesting thing to note that this threshold might not work for every year, and there are variations in every year. And yeah, you can see, as I mentioned earlier, there's like the bimodal peak pattern. There's like a small peak in April and May, and then a larger peak in July and August. And also, these circles I have up here represent the lunar phases. So the blue circles are for full moons, and then the gray circles are for new moons, and you can see that there is a correlation as well. So there's a peak whenever there's like a full or new moon, there's a peak, and then around the end, there's like a little bit of a lag between when the spawning peaks are and when the phases are, but that's also normal for the data. Yeah. I thought this was really interesting. And then here is a discussion of the data looking back. Since my data was cut off in mid-August, it was important to look back at other data and see what patterns could have arisen. And you can see that this is data from 2004 and it was published in 2007. And the spawning sounds decreased in duration by the end of August and September, and then it would be completely done by early October. And there's also a similar pattern with the lunar phases, as you can see here. And due to the difference in years, there are some factors that might change from year to year, which could have influenced my year for 2017. But we have a whole set of data for the whole decade, and it's important to look at all of it holistically in order to make observations about the patterns that occur from year to year, and hopefully learn a lot more about the spotted sea trout. So thank you to everyone who helped me with this internship. Here are some acknowledgments. And here are my references. Are there any questions?
Thank you, Michelle. Excellent job. And Michelle will take questions if anyone has any. You can type them in your chat, or I have also enabled your microphones. So if you want to speak, you can do that. You still would need to go up to the top bar of your Adobe and select to turn on your microphone. So we'll give it a minute to see if someone has a question. Looks like Claudia is typing one. Can you view it, Michelle? And if you can you read that out loud before you answer it, please?
Yeah. So Claudia asked, do you know if there are other factors aside from temperature that would be expected to affect sea trout calls? Yeah. Besides temperature and like the presence of predators, there are red tides that affect the west coast of Florida, and that's also an important thing to consider. I looked at the data for red tides briefly, and there was a red tide in like 2015 and 2016, and it subsided right before the spawning season for 2017, which I thought it was interesting, and it could have affected the intensity of the sea trout calls, which is why they didn't last as long, or like the 3-hour consistent spawning time was not prevalent throughout the season, as you can see. And also, Sarah had mentioned that it takes like 3 to 4 years for the sea trout to recover from a red tide. So that can be an important factor that affects the calls.
Great, thank you, Michelle. Does anybody else have any questions? All right, well, Michelle, again, excellent job. I want to also acknowledge to everyone who's in attendance that the interns had varying levels of experience with, just analyzing data or graphing, and our intern Stephanie Maxon walked everyone through a presentation she created on Excel and using functions and graphing. And so I believe Michelle was relatively new, but she put together all these amazing figures and did all of these analyses by herself with the assistance after learning. But Michelle, very well done. Thank you. You can tell a lot of
Thank
thought
you.
has been put into it. So we are super excited to have all this great data from our interns to now go and take a look at over a long period of time what's been going on with our spawning aggregation. So we're very impressed with everyone, and to everyone who came today, thank you so much for your attendance and your support.
Thank you.